Hello, and welcome to the Actuarial Data Scientists. In today's video, we're going to be discussing a potential shortcut you can take when calculating sample averages or means, as well as then feeding that into just a more traditional exponential question. So feel free to pause the video here if you need to read the problem, otherwise we're going to go ahead and move forward. So for this, we need to know first off that when you want to estimate an exponential distribution, all you need is that estimator for your theta, and that's just going to be your sample average. Additionally, you need to know how to use a CDF, so that's the probability of being less than or equal to a specified value, and in this problem we're actually interested in the opposite of that. Technically it's called the survival function, but here we're just saying what's the probability of being greater than or equal to something. That's going to be 1 minus the probability of being less than that. And then finally, and really the crux of this problem, is how to calculate a sample average. So conceptually, so let me first say that what you can do for this problem, scrolling back up for a moment, we could take the integration of this uniform weight and then do x times the PDF and formally calculate that all out using integrals. So that is one way to do this problem. However, you can kind of take a shortcut by just knowing that the sample average is the same as saying the probability of seeing any given value corresponds to some weight, and the average is going to be the location that you could put a fulcrum where the scale is balanced. So in this case, this little simulation I have here, let's say you have 4 data points. You have those 2 blue blocks and those 2 green blocks, so they each have 25% weight. And you have that average is where that triangle is. Just looking at this, that's the location of the average, but if you move points away from each other the same distance, that doesn't change where that fulcrum is going to be in terms of that balancing point. And so kind of knowing that correspondence between the average is really just that balancing point, you can actually take a shortcut. And this is really just a conceptual shortcut for taking that integration and doing it the more basic way. But for example, here what we have is the PDF, or I guess this would be the empirical PDF since it's a sample and not the actual distribution. But this is just looking at the number of data points divided by the total number of data points and then making it such that the area corresponds to that amount of weight. So for this very first section, it's 0.005, and that's because we have 5,000 divided by 10,000, and then we have to spread that weight equally across this width of 100. Now, going back to our fulcrum analogy that we have, let me scroll on down. What you see here is we have that PDF, and you can think of that as those blocks on the scale. And then what we're choosing to do is just think of the central location. And because it's uniform, we can just move everything to the center and then consider the overall weight in that section. So again, what we just calculated previously was that first 0 to 100, we know 50% of the weight is there. And so instead of making it complicated and thinking of it ranging from 0 to 100, we know it won't change the calculation for the sample average if we just say that all of that data is located at that midpoint. And so here we can just say 50% of the data occurs exactly at x equals 50. And by doing that, we just are taking a shortcut. So I apologize for the rambling explanation, but all of this is to say you can just take the shortcut of considering the midpoints of those ranges and then putting all the corresponding weight directly at that point. So 50% of the weight is going to be at x equals 50, 30% at 300, so on and so forth. We then can calculate our sample average, so that's just taking the probability weighted average of those values, and then we get a theta hat of 377.5. So at this point, we then need to answer the actual question, which was, what is the probability that a loss exceeds 500? And so 1 minus the CDF is what we have here. Those 1's cancel, and then all you're left with is e to the negative 500 over that theta hat. And so we end up with an answer of 26.6%. And scrolling up, we see that falls in the range of C. So that's our final answer. As always, thanks for watching. I appreciate you taking the time. Please consider subscribing if you find these videos helpful, and comment below of any other specific questions you would like me to cover. Otherwise, I'll see you next time. Bye.